Welcome, guys, to another ChronoLogic live stream. Hope you guys are doing great. Joseph here with Piotr to give you an update on some of the stuff that we are working on. Today we have two topics for you. One of them is a new integration that we are doing with DAppNode, and another one is some updates on the research in regards to conditional scheduling, which will be shown to you by Piotr. So, Piotr, say hi to everyone.
Hey, what's up, guys? I hope you're doing good. Yeah, let's kick it up, Joseph.
Let's get started. So, guys, could somebody drop like a one in the chat so that so that we know that you guys are able to hear us? Okay. Okay, we'll assume then you guys can hear us, and let's just go ahead with the webinar. So let's kick it off with a couple of dev updates that we have in regards to our releases. So we have the new version of the Chronos app running. So it's version 1.2. It's live on GitHub. We sent a notification on Telegram, so hopefully you guys have already updated and you're using the latest version. We have a couple of new updates for you guys from the last webinar we had 2 weeks ago, where we updated you on some of these. But now we have some new features in the TimeNode. So basically, TimeNodes now prioritize transactions with higher bounties. So if there are more transactions in a single block with different bounties, the TimeNodes will automatically prioritize the one with the highest bounty. So this is something that we feel will run the TimeNodes a lot smoother and make them a lot more profitable. Another thing we have added is we have added a total ETH transferred counter. So basically now when you go to the DApp, you can see how much Ether was transferred in total using the Ethereum alarm clock. So this is something I think this was like pretty valuable so that we can see how people are using the Ethereum alarm clock and what is kind of like the adoption when it comes to this. And this is entirely decentralized and you guys can fetch all the, and you can check all this data. We have also improved some of these loading progresses with transaction details and some of the lists, and we have also updated the dependencies. So you can go ahead and check it out. The latest release of our Chronos app on the link. You can see the link below here.
And here, actually, I just want to jump in because I just read like earlier today, there was like a huge security issue with one of the NPM packages. It's called like event stream, I think. So the whole story was that the guy who was like originally like building and maintaining the package gave out the control to some like third party, right? And then this guy basically injected some like malicious code. So what I did actually this morning is that I checked like if our software using this package, but no. So just you can feel safe with the time nodes, both CLI and the Electron and everything we just created. So no worries about that. And okay, continue, please, Joseph.
Great point, Peter. Great point. So let's just go through the agenda for today. So what we have is a small introduction to what DAppNode actually is and how you can run a TimeNode on DAppNode. It's kind of a mouthful, TimeNode on DAppNode, but you guys can see it's something pretty cool. So then we'll go through a short demo. I'll show you guys how this actually works and how it looks. And later, I'll give it off to Piotr to continue with conditional scheduling. And let's jump into it. So basically, DAppNode. What is DAppNode? So DAppNode is a product run by a bunch of cool guys, and what they have built is a all-in-one decentralized node manager. So basically, the idea is to have a simple manager for running an Ethereum node and running decentralized applications on this Ethereum node. So what they have integrated within this ecosystem is a local Ethereum node, which automatically updates to the latest version. And they've also added a nice user interface for kind of like a store for installing decentralized applications. So basically, once you install these decentralized applications, they automatically connect to the same node that you are also running, and they make it work really seamlessly, and it's pretty much very easy to use, very user friendly. And with this product, they are aiming to achieve a bigger decentralization, because currently what we have is you have services like Infura who offer decentralized nodes, but if everybody connects to the same URL, same node, then there's like kind of like a point of failure. So what they want to do is they want to make the ecosystem more decentralized and easier and they want to bring this closer to people so that everybody can run their own node and automatically build and connect the apps to this node. So basically, the DAppNode UI looks something like this. So you have it. So once you install the DAppNode, you connect to it, and you have a UI like this. So you have the installer on the left-hand side. If you press on this installer, it gives you like a small search of some available applications for the TimeNode. For the DAppNode, and what you can do here is you can search for a specific package, and you can also add some other dApps. If you are a dApp developer, you can add something here. So what we have done is we have put the TimeNode on the DAppNode installer, so that it's easy for anyone who's running a DAppNode to install it and automatically connect it to his node. So the installation process goes something like this. So you would install a DAppNode. Once you have it installed, you would go to the installer section and you would search for timenode.public.dappnode.eth, which is the ENS DNS path to our TimeNode application. So once you search for that, as you can see on the right-hand side, you will be greeted with a huge Ethereum alarm clock icon and an install button. So basically pressing the install button would add the TimeNode to the packages section. So you can see here we have the TimeNode running and the package says version 1.0. So once you have it there, you are ready to run it. So what you would do then is you would go to my.timenode.public.dappnode.eth and /timenode, and basically you would get to this screen where you have the TimeNode up and running. And this is now a fully decentralized way of accessing and fully independent way of accessing a dApp. So if you guys are keen on running your own DAppNode, you can follow this URL. And basically here, what you can do is you can install a DAppNode on your own machine, or maybe in like a cloud service like Amazon AWS or DigitalOcean or Azure or something like that, and you can run your own DAppNode and manage it, and you can install a TimeNode on it. So if you guys care for decentralization, and if you guys care for making the ecosystem like a better place, so you guys can also go ahead and check it out. I'll do a short demo so you guys can see how this looks. So if we follow the installation guide, here's the installation guide that the DAppNode guys have set up for us. It's pretty straightforward. So it shows you how to install a DAppNode from an ISO or how to install it on a Ubuntu server. So what I suggest you guys to do is to try this one, how to install DAppNode on your Ubuntu server, and they have prepared just a couple of commands that you paste in the terminal of your Ubuntu server, and you can basically connect to your DAppNode. So I have connected to mine, so I'll build it on the DigitalOcean droplet, and I have connected to it through my VPN. And now I have this URL, you guys can see my.admin.dmp DAppNode. So basically this is my admin interface for the DAppNode. So you guys see, you can see here the status of the DAppNode. You see everything is connected. Mainnet, the mainnet chain is already synced here. We have IPFS running here. And if we would go here on the left-hand side to the installer, you guys can already see our DApp is now here. and you can also search for it. So if you write TimeNode, you guys can see that the DAppNode is here, the TimeNode, and you can see all the version number and everything. So basically, this is how you would install it. And you see my DAppNode is my TimeNode is running. So if I click here, if I click open, I get this link. It says a use link, my TimeNode public DAppNode.eth. So I'll just copy this. I'll go here, paste it, and it should point me to. Yep, you can see our Chronos Dapp running here, and you can see we can connect to the TimeNode here. So while we're at it, I'll also show you guys this. So we have this counter. It shows how much ETH was transferred using the Ethereum alarm clock. So this is also one of the new features I mentioned earlier. So this is like a short introduction to how to run the TimeNode. So on DAppNode. So if you guys are keen on trying this out, go ahead, test it out. The DAppNode guys are super helpful. So you guys can also join their Riot channel if you guys have any questions. But they also have some other dApps here that you can automatically install and connect to your node.
Yeah, so, and I think it's really important to add actually that this way of running the node, like the TimeNode, our software is, I would say that's the most secure way, because actually you have the package that is stored on IPFS, it's immutable, and then you just run the code that you know that no one really do anything with that. Obviously you need to trust at this moment us, so we publish like the good package, but that's obviously in our best business obviously. But what I'm saying, you have all these issues with DNS hijacks and all these kind of problems, right? So it might happen and that did happen with Might Wallet, other vendors. Basically someone hijacked the DNS and then just replaced the wallet essentially. So this is by far the most secure way, and that's obviously also the reason why my crypto and we as well just recommending running the TimeNode locally, so from the Electron app, from your own system, right? On the other hand, when you run on your own system, then you might be exposed to all these viruses and all these bad things that may happen in your system, right? But that's anyway much more secure than running in the web browser. So just this small remark from my side on this.
Exactly, good point to add. Great point. So basically, this might be a bit of a hassle to set this DAppNode up, and but they have really clear instructions on how to do it, and I found it quite easy.
So I was able to do that and complete. I think it's not really too hard, and just additionally, I think I'm not sure if that's the DAppNode crew or someone else, but I think someone is essentially prepping the dedicated hardware for that. So you just buy a box, you just install it, or it's probably pre-installed, and then you can just place on your home. And this is your full node with all the transaction information. So this is the best way to access the Ethereum, right? I really like, and I personally just cheer for this project quite a lot.
Exactly. I think this is in DAppNode's agenda. I think that's the ultimate goal, to have a full solution for a node, both physical and software, both hardware and software.
Totally. Yep.
Okay. So let's continue onwards to conditional scheduling. So I'll give it off to you, Piotr.
Yeah, guys. So we just wanna just present you a couple of the things that we've been working on, for quite a long time now. It just takes quite a lot of things. We just going with this cycle of researching and then building the prototypes and then trying to figure out what went wrong and all that stuff. So that takes time, obviously, but that actually makes us, think a lot about the problem and the space of scheduling, or the execution without the gas and all these related things. So yeah, I want to just give you a short, brief update on where we are now. We just don't want to spoil everything because there is quite a lot of things that we have, but we just for now just keep it until we feel much more comfortable, so we can just put it, and then it's going to end up as a white paper probably free for all, and then we also want to deliver the implementation as usually. So okay, let's go, Joseph, to the next slide. So here is just like a very simple overview of version 2 of the Khronos. So just to give you the better understanding, the Khronos that we've been discussing and working on, so conditional scheduling, it's just like another version of the Khronos. I know it's a little bit misleading, but for us it means that we've been working and researching the conditional scheduling since like May or June, then for a couple of some time. And then we figured that the way actually we wanted to build, it's not really doable, and there is quite a lot of problems, and so on and so forth. So this is basically the latest, research, the results of the latest research. Some of these parts are already implemented and working pretty well. But just let me go you through the whole thing. So on the left-hand side, the blue ones, you see like the simple couple of the steps of this protocol from the user point of view. So someone who is like scheduling or ordering, the request for the scheduling, for the conditional scheduling. On the right hand side, you see the steps that actually are performed by the nodes. So the relayers, or the time node in our vocabulary. And yeah, so basically, first thing is obviously that the user published the watch request to the Khronos relay network. You can see that pretty much, if you ever use the Uber, the drivers, application, the application for like hailing the drive. It's pretty much the same. So you put like on the network, and in Uber you have some geographic algorithms, so they contact you, so they match you with the best match. Is someone like going to end the ride next to you, or maybe it's close to you, and so on and so forth, right? So this is pretty much the same idea. And here now, so we're publishing the request to the network, and then on the other hand, you have like a bunch of Khronos relayers using this relay network that looking and listening to those requests. So when you publish the thing, you also propose the asset that you want to propose as a payment, right? So this is much more general than proposing the Ether. You can propose any token, essentially, whatever, like NFTs, all the assets, actually, whatever on the Ethereum, right? And then you have this like bidding process that's happening, because you says like, okay, I want this conditional schedule transaction to happen, and I'm willing to pay like 2 CryptoKitties, or like 2 day tokens, or maybe some part of Ether, or maybe something else. And then, because this is like very interactive process, you have on the other hand the time nodes that actually can see like whether they want to accept this as a reward, or maybe they don't want to accept it. They actually can calculate automatically, like if this is a token, what does this mean in the ETH terms, maybe in USD terms, whatever, right? So the decisioning is on the time node side. So they can accept and send the offer, like, yes, I'm gonna do that, and I want like this amount of these tokens, right? Because when you do proposal, you might send like, I want to pay with this token, but I don't need to really disclose the number, I mean the amount that I willing to pay, which means that this is kind of the auction. This is actually the auction. So the time node says like, okay, there is like this token on the stake. I want to like 5 of these tokens, or maybe like 1 ETH for the execution. And then after time, so this is like partially synchronous protocol. The whoever was waiting for, who was sending the request, can choose based on money and time, essentially the best offer. So someone says like, so you imagine that like I said like, hey, I want this to be executed, and then you get, okay, time node 1 says like, hey, I will execute, I need like 3 day tokens, and the time node B says like, hey, I want to execute, I want 5 day tokens, and the node number 3 says like, hey, I want to execute, I want to just have like 1 token. So now it's quite easy to pick like the cheapest offer, or whatever, like whatever the strategy you have. Probably the cheapest is the most like logical one. And yes, so if you accept the offer, you just exchange the signed messages, and the time node is starting to watching your transactions, your conditional scheduling, conditional transaction, right? So why the whole thing is like that kind of complicated, because the difference between the general conditional scheduling and time-based scheduling is that you don't really know when these conditions gonna be, fulfilled or like basically true, so you can actually do the execution. Because this is very asynchronous and really non-deterministic, thing. So we switch from the version 1 of our thinking of the research that there is actually like some sort of reward, like you want to say like, I want to pay you like this, and you're gonna watch it, right? But this might be like lead to some of the attack vectors on the time nodes, because if someone accepts this offer and then actually this condition might never get through, might never be like fulfilled. So what does it mean for the time node is like infinitely, watch the state. So burning his resources, like, network and all this, CPU and all that stuff, but never gets rewarded for this. So that's why we change it to more of the subscription or like rent approach, which means that here I says like, you propose the asset, but in fact what the title says is that, okay, I'm gonna watch, but I want to have like 3-day tokens per like 1 day. Like it's like a bad example, like 3-day tokens every like 5 minutes or every 1 hour. So you essentially, the time node brings you the price for the subscription for watching the state and doing the execution. So that's basically the biggest change. So could you go further, Joseph? Okay, thank you. And basically, when you look at this, there is like a couple of the building blocks that we are, we just divide the whole Khronos, and we just, just implementing like a basic MVP, so minimum viable product on top of that. So we have like a decentralized storage. Here you can use Swarm or IPFS. Also looking into using the internal storage for the time nodes. Relay peer-to-peer network. So this is the network design that allows all this like bidding and communication between the time nodes and the people who are willing to get something, to get executed. Execution proofs. So this is like by far the hardest part, which means like I just want to give you one example, is that if I order, this conditional execution to happen, and some time node is just observing, but what may happen is that this node might just didn't execute it, even though the condition was true, and just withhold my transaction, because maybe I want to sell like, a bunch of tokens or Eath or whatever, and all of a sudden this time node says like, hey, I'm not going to execute it, because it could do that, and that was the problem with the version 1, because there is no way to send the proof by any other time nodes and says like, hey, this time node says is going to execute, the state was like it's supposed to be, but no execution happened. So in that case, and that's the reason for having the staking contract, is that this is like now verifiable by any other time node. Which means like if someone withhold the execution and it's supposed to execute but didn't, there is a way for the time nodes to just signal that and get the reward. So potentially this misbehaving time node will lose the staking deposit. So that's the difference, right? And then obviously you need to have like user client and the relayer client, which is like JavaScript or whatever. So the way to run the software that's analogy to the time node, and obviously the libraries that, for instance, we're using to integrate with the wallets. Okay, so yeah, this is very quick. Like the changes from V1 to V2. V1, I mean, we talk about the conditional scheduling all the time, and if you've been attending to our previous webinars, you know that we've been like trying to figure a way to make a priority queue based on the amount of the day tokens. But this actually is quite a problematic, because I mean it works if we talk about these time-based scheduling, but doesn't really work if you talk about like the conditional scheduling, because all of a sudden is that how you want to like the priority. Well, we could do the priority for the bidding, as a kind of weight thing, like the some factors. So your actually bidding is like more valuable than the others. On the other hand, we probably gonna use the day tokens as a staking thing, which means that it's just to be a security. Security means, so if someone just don't execute and supposed, then it's gonna lose the day tokens. And as I explained before, we are switching from the one-time reward, which is the case for the Ethereum alarm clock, to the subscription-based, which means that if you are, if you get accepted the request, your offer by the person who wants to something to get executed, you're gonna essentially get money down the road, which means like if whatever the execution happened or not, you're gonna get paid like some fraction of this reward, right? During the time, because you are online, and then you keep watching on the state, so you're burning resources. And that's obviously, again, I want to emphasize that is difference, because with the time scheduling, you know exactly when this execution should happen, and that's exactly how the TimeNode works. So they activate themselves just 1 hour before the execution, and that's why if I says like I can that's why you can actually schedule like from 1 year from now, but none of this TimeNodes gets any action, because they know that the time 1 year is exactly 1 year from now, right? So they want to go to 1 year minus 1 hour and then do the actions and start like negotiating and claiming and so on and so forth. Another advantage of that, of having actually the peer-to-peer network, is that you can actually make most of those operations just off-chain, which means that we should probably, and that's our goal, but by doing this we actually eliminate the racing problem or the collision problem, which is a problem obviously for the Ethereum alarm clock. So that's the reason why we're changing that. And yes, and the new thing that is obviously what I explained as well. So the execution proofs or the missed execution proofs. So the way to the other time nodes to prove via the smart contract that something did happen, but some other time node didn't react on that. All right, so that's pretty much on the research part. I know it was like quite a lot of information for you, so I encourage you to just ask questions on the Telegram. You know how to find me. Just send me the DM if you have some questions, or if you wanna take an active part in the research, just ping us. We just gladly get into all these discussions. We're building this for quite a long time. We obviously very excited because now we get like these new ideas that we're building, and they seem to work. Sure, we just gonna get this like when it's gonna be like published live, it means that we confident enough and we feel it's a really good stuff. Okay, so I think that's it from my end. Joseph?
That's pretty much it, guys. Yeah. So thanks for the update, Piotr. Guys, if you haven't already, you guys can schedule your transactions today. So if you guys have any, if you guys want to schedule any transactions, just go to chronologic.network/schedule, and you have all the instructions there. So yeah, just keep on scheduling, guys. Cheers. And if you guys have any questions, we can also go through a couple. So you guys are free to post any questions in the chat box below. I think this one was pretty clear. So yeah, guys, just let's keep in touch on the Telegram channel. Send us any questions that you might have in regards to either conditional scheduling or DAppNode. We are glad to help you guys with any questions that you might have. So thank you for joining us today, and we wish you a pleasant rest of the week.
Hey, thank you, Martin. I saw your comment. Thank you. So take care, guys, again. Thank you. See you next time.
Yeah. See you next time. Bye.